So I saw IntelliJ stickers during the break, and I remember some important thing. Maybe anyone uses IntelliJ? All right. So maybe you know that BellSoft supports IntelliJ runtime. Currently, we made some tweaks, and also we integrate security fixes into that tree. And we are located in the same city in St. Petersburg. Our good friends. What I'm going to talk about next is containers. Let's try it. So the talk is mostly two parts. One is slides, and one is some live coding. Something might break, but please don't beat me. I'll try to fix it. Okay, I will decide when. So we live, okay, the year is right. I'm not sure if you have, I think you have this thing, which may be considered a container. And when you work with container, which is something, well, something that encapsulates some other something, you have expectations of it, of having something inside. But it's something you didn't see. So your expectations may be not met. By the way, this happens because of marketing stuff. So this year it started to be like this. When you buy eggs in shop, you have 9 for a price of 10. That's great. So what containers are? It is a very simple thing. It is just a configuration, because there is a real stuff which is called Linux containers, and it is a technology of Linux kernel that allows you, well, to distribute resources and visibility of things between processes that you have in your system. So basically, two main words, namespaces and control groups, that defines what a process will see and how much resources it may use. And this technology is not a virtualization. So in any case, you're running on the same kernel of same host operating system, which, by the way, may be Windows running Linux containers. And it's not a virtualization. So process inside a container may see some information about the entire machine, about its neighbors. That depends on what you have set up for this process. And this is the configuration. And to make this configuration easier, there are different tools. They have different specialization. For example, pneumo control or task set is kind of such tool. When you start process with pneumo control, you start a container. In fact, you always have a container with your root shell and other processes. And on top of that, tools that, like Docker, that manage that configuration, there are tools of higher levels, tools that manage tools, that do orchestration, finally allows you to write some YAML, which is a new must-have programming language. And when we use all that stuff, is it a problem for a process to run in container? Well, no, not a problem. You just take some program, take container technology, any tool, and you put that program in a certain environment, and then something might happen. But if that program doesn't care, well, why should it care? Maybe its creators decided to make some Java runtime 6 and run industrial jar, And it works until it breaks. But it's happy. Yes, JVM is a kind of program, but a very special program. Because imagine you're running Hello World. Now, it's a single-threaded program without any tricks, no dynamic stuff. You just print Hello World. But you still have class loading, garbage collection. With some flags, you may get compilation, dynamic compilation, or ahead-of-time compilation. So JVM has the same complexity. It doesn't matter what program it runs. And when we use that complex beast in container, we expect something. Why do we actually put something in a container? To provide it a reproducible environment. So a program may think that, okay, I have very same configuration, very same set of libraries, because the kernel may be different, but it's still same. There's a certain set of libraries, set of open resources like ports or disk mounts available. We expect some kind of isolation, which is provided by operating system, who can just punish a process that behaves badly. From the other perspective, when we run some programs in containers on our host machine, probably if you put Java there, we won't be using JDK, because what for? We just need JRE, if you talk about Java 8, for example. Or we will use JLink or something to provide limited environment, less surface for problems, less tools, but if you don't need them, why should we have them? And we expect to work with that containers from outside, like from a host machine, to do all the things that we like to do. Like kill program, maybe debug it, but at least kill -free. Not killing completely, but taking some information out of it. So, it's clear that something needs to be changed in JVM to support all that expectations. And this work started in JDK 9. The initial problem is that all your programs and your JVMs must not crash. That's a definitive requirement. Like if you put some extra configuration, why should you fail because of GC? No, it must work. And most actively used limits are, of course, limits for CPU and for memory available to a container. Because one of possible goals is to put a lot of containers on one host to run kind of independently, but sharing actual physical resources. So the work started with support for very basic flag that allows you to encounter CPUs being used for this process. And memory limitations, at least to size heap somehow accordingly to limits for that container that JVM runs in. That work continued in JDK 10. Because there are other ways, other means to set processor resources for a container. Like for example in Docker, there are multiple flags that allow you like just to denote the count of processors being used, or even CPU quota or period, like more complicated setup. And some flags were provided for a JVM user, also to try changing settings without using containers, for example. And there was a flag use container support, just in JDK. Also, For memory limitations, some new flags were introduced to make fine-grained tuning of heap. And the work started to allow tools from JDK work from host, then talking to Java processes working in containers on that host. So this work was completed in JDK 11. Like finally, JCMD works, JPS works. Like you run JPS, you don't see Java processes. Kind of unexpected, right? Also, there was one more flag for setting up CPU limitations. And finally, extra flags for memory. And also diagnostic information when you, for example, print system settings. You can now find out something about container, then you not just finding something about your entire host system. And JDK 9, JDK 10, JDK 11, somewhere there were like deprecations, removal of deprecations. You know, it happens from release to release. But let me ask you a question. What's the best JDK ever?
The one yet
The
to
one
come.
that you have.
Non-typical answer.
Ah,
Of course it's JDK 8. Also, it's like typically 80–90% of users using still JDK 8, which is, like you may see, current JDK 8 is way ahead of JDK 8 GA. Like in different updates of JDK 8, container functionality was ported in, like from JDK 9. So some updates of 8 got features of JDK 9. Then JDK 10, including deprecation and new flags. And then JDK 11, including deprecation and new flags. And finally, they're more or less, good, right? Except you don't know what flags to expect from your JDK 8 update. So please use latest update, at least it's more or less equal to 11. But what about next fixes? Like this. Yeah. It's unlikely that other functionality that is not critical will be ported to 8. It may happen if it's considered a bug, like something fails, for example, GC fails again or something else. But yeah, that's a test for American auditory, for audience here. Do you know world record egg? Really?
No.
Okay, this girl?
It's like Kardashian.
Wow. Appreciate it. Okay. Okay, just some
Explain it.
side story. Okay. It's called Kendall Jenner, Kardashian sister. So she was close to making Instagram likes record. Posted a picture of a baby, or I don't remember. But then this thing appeared. It's called World Record Egg, and it became the top of Instagram. I'm not sure about now, but that's the story. Okay.
why is he so popular?
It's
It's a world
Because it's so cute. It's an egg. It's a net effect. All right, so now good updates from newer JDKs. So in JDK 12, for example, G1 started to give unused memory back to operating system, which allows you to have sum of memory limits of running containers greater than your physical memory. Right? It's not a problem until you have real physical memory used. Right? And other GCs are also able to do that. Like Shenandoah does that, ZGC does that. And in JDK 13 and next JDKs, the work is planned to be around diagnostics. So there's a command line option to print something, then JVM starts. Probably not the best diagnostics, but still much better than nothing. So it's better to use mission control. By the way, you can download release mission control binaries called Liberica mission control from our website. So we crafted that and it works with any OpenJDK. So you need, of course, JMX bin that will expose additional information about host system, and you need some support in mission control to show that, display that to the user. Also interesting part would be support for NUMO memory, which is kind of tricky, but it may give a better performance. So it's not about fixing crashes, but it's about performance now. So that's theory. Well, a lot of work in JDK. But what we typically do, we develop an application using all that funny pictures, elephants, whales. Yeah. So elephants go to whales or otherwise reverse. But we want to make our program bundled as something, deploy it somewhere, probably in the cloud. We hope that it will be okay. It won't be killed by operating system in that cruel container. So we test it in the same container in our test environment, and we may even develop it in the same container in our development environment. So I start to support that. But, for example, Docker containers support layered layout, because when we deploy our application every second, which we all do, or maybe every minute or so, we don't want to put too much traffic to servers, getting updated container images, anything. So, in case of Spring Boot, for example, we might have a fat jar which contains Spring itself, some libraries for our application, and a very tiny part of business logic. One interesting approach here would be to make it not a fat jar, but a thin jar, where we can separately deliver business logic, which is updated very frequently, libraries that are updated much less frequently, or Spring, which we maybe update once or 2 times a year, I hope, at least. And there's also a layer for Java. So there are different approaches here. You may craft your own custom runtime using JLink, which takes time, and sometimes it may be tricky because of your dynamic dependencies, things like that. So we'll look at a bit different approach here. But this is an important layer. And there is, of course, layer which is not shown here, is operating system. Well, it's actually a set of libraries, not an operating system, because we don't start a virtual machine at the container, but yeah. For simplicity, we call it OS. But where do we get a base layer for Java and operating system? For example, we cannot get an image with Oracle Java, because all such things were removed by law. But you can go to other places. There's some good stuff that we discussed previously in my first talk. One of channels where we deliver Liberica is Docker Hub. Not only we do that. So let's see latest updates. 8, of course, the best JDK ever. you see JRE numbers and JDK numbers like X2 or yeah, like this. 600, maybe sometimes 700 megabytes. Do you like it? No, but we have JDK 13. The size equal to size of JRE 8. That's the power of module system, because we can make them squash it a bit, more freedom in that space, and we can do a especially good thing. We can create a runtime basic base image that will be below 40 megabytes. Let's look at that. Okay, so it's my terminal. The tab is called alpine-musl. What's this? Let's switch again, but slowly. This is my browser. This is Docker Hub. So you can find alpine-musl. Oh. What is Liberica? All the information. And you can find some instructions here. They are really simple. The idea behind the thing is that, first of all, for those of you who are not familiar with alpine-musl, in general, this is a basic flavor of Alpine Linux, where standard C library is not glibc, but is musl. It's much smaller than glibc. It's slightly different in behavior. And if you use only that library and you don't have any glibc in your system, you have to recompile your programs, like JVM, for example, not jars, of course. And we do that with Java. This thing is called Project Portola. It's not mainline yet, but it passes TCK, and there's JEP draft about that, submitted by myself. So, yeah.
Is there a performance difference between glibc and musl?
Yeah, sometimes. It may be faster, maybe slower, because it's smaller. And especially it's faster than musl plus glibc layer. So you're still able to run regular glibc compatible programs, then install glibc layer that actually does calls to musl. That's what's called just, for example, Liberica, OpenJDK, Alpine. It's alpine-musl plus glibc layer and regular glibc Liberica. Alpine-musl is interesting because it's smaller. So the OS layer is like 4 megabytes, and then they have some Java layer. And what we provide is a tool. Okay. Is a tool to build your base image for other Docker images. So we take some prepared Liberica and we carve either a very small base image, being able to run, for example, command line programs referring only Java.base module. Or it may be a very typical one called Lite, which is able to run typical server applications, not having additional modules that you don't need probably from JDK. So it will be around 100 megabytes. Or you can create a thing that is called full, if you really need full JDK. And it will still be small. So we can run it. So it's a Docker build with parameter. It's very simple. You just get one Docker file, then you call Docker build, and it builds. So let me switch back to slides, because it may take some time. What other images are there? Java's like 8, 9, 10, 11, 12, 13. Everything is there. Free Linux flavors plus, so Alpine, CentOS, and JVM. And Alpine may be just Alpine or alpine-musl. And few architectures, ARMs, and x86 of course, and we also have images for Windows Server, which are also kind of Linux but special. Let's check what happened there. Okay. Looks like we're okay. And it's 39.5 megabytes. So it is a base image that is able to run simple programs. It's comparable with Go. And if you add modules in your Go program, you also get larger runtime, a larger image. So I would use Go. Oh, for a quick start. Okay. So, now we get back to the main demo. I'll try to sit like this. What we are going to look at. We'll open a terminal. Maybe. Okay.
Work okay for you?
Yeah, yeah. If you hear me fine, I'm good. So what do I have here? Few tabs. First tab is called Service. Here I am SSH to remote server, where you see I have a fat jar. It is really a fat jar. It is a microservice. Microservice 2019, 17 megabytes. And what it does, it says hello world, but it also provides well, nice health checks, things like that. We really need this functionality because otherwise it is not a real microservice. No health checks? No way. And there's, by the way, the thin jar. That looks more like hello world, right? It's only 90 kilobytes. I also have libraries unpacked here. So we'll start to experiment with fat jar. So let's run it. What happens here? No containers. We just run Java 8, java-jar.
It's a Spring Boot app.
Yeah, it's Spring Boot. And it boots for some time. Let's talk about health checks. Okay, it's not healthy yet. So it still initializes. So this tab is called health. Simple JSON health check works here. So it requests the health check status and also that hello world REST endpoint. Okay, so we got it. It's up 17 megabytes, Spring Boot. And I should say that it started in about 20 seconds or more. It's a microservice, as you know. So what's next? I'm greedy, and I'm excited about containers. So what I'm going to do is to take this microservice, put it in a container. It's not like a Liberica base image, but just operating system image. So I put JDK on the volume here. But anyway, and as I'm greedy, I will give it only 5 megabytes of memory. It's hello world, right?
Spring Boot.
It's Spring Boot. It's so agile, so flexible. Let's start it. I think this time it will start much faster because it dies right now. Oh, it already did. But do you think it's normal? Like, it died silently. Do you typically see Java processes dying in complete silence? No. Because we like them being talking about it, showing us some exceptions, trying to catch signals from operating system.
We're seg fault.
Yeah. Printing nice information about seg faults. So, well, let's check. So here I ran magic cast, and I look into system journal because system tools tell me the truth. And they tell that process has been killed because of C group memory limit. And yeah, it's all red, but it didn't say me anything. All right. This time, I won't be using a container. Oh, sorry, I will. We'll check flags. So you see heaps flags for this process, and we start it. It tries to grab not 5 megabytes, but much, much more. It tries to use, well, a big chunk of physical memory available on this host. Because it's JDK 8 and it's not JDK 8GA, it's some security update, functional update. So how do we deal with this? Oh, sorry. Okay,
Can't kill us.
something breaks. Instead, we might remove container stuff and see how Java process behaves nicely. Then we just put small heap in its parameters. Let's say just use 10 megabyte heap. Will it be fine? It will die, but it will report at least some exception. So we'll know that something bad happened, and we'll see it in regular logs. I don't know why it's not. Oh, okay. We'll just start. So it will try to survive, do its best, but 10 megabytes. That's it. That's what to expect. As a developer, I like to see this long, stack traces from Spring Boot. Okay. But how would we find out what memory limitation we should use for our container? Some places offer you static tools that look at your, I don't know, jar or something and say you need that much memory. That sounds scary. The only way to find it out is to look at your program that it's running and to check actual native memory that you need. And there's a good thing to do it. It's called native memory tracking. So we put native memory tracking flags to our service. No container here. We can create some container with for sure known enough limits, but we don't have to. So we start our process and we do tracking. It starts. From the other side, we start J command and ask this process about its native memory at the time that we consider a write time. Like after it started, or probably after it received some load, then it's stable, and we know that it consumes its memory, not less. Here we see total committed memory. So this process was started with entire host limitations. So it tries to grab slightly more than it really needs. But we can subtract actual heap from this value, and to get memory limitation for a physical memory that this process needs. And for this process, for this microservice, it is a limitation of a few hundreds of megabytes physical memory. So, we should stop it. But, as you remember, I'm greedy, which means I still want to put much less memory to let it work. I say, so I'm a magician, I say you work with 128 megabytes, and we'll see what happens. As I said, it works. We can even check Docker stats. So we started the container with limitation -m 128 megabytes. So we check stats, and it consumes not more than this limit. My magic works. It's good to be greedy. But what happens in fact?
It's swapping.
Right, exactly. So you should apply for a senior. Yeah. How could we see it? For example, we can use system tools. Like we can find the speed of this process to ask PMAP about it. And you see, so it's kilobytes. So it uses lots of swap. What's worse, it's a shared thing. So maybe someone else really needs that swap. So then swap limitations will end up. We cannot predict which process will be killed. This bad guy or someone else. They don't know. And second thing here is that it's extremely slow. I forgot to run JMeter for my initial service, but it does like 500 requests per second. Like I queried from another machine which is slightly weaker than this one. But anyway, then I start doing this the swap involved. It is much less. So yeah, it will be killed anyway because it continues to consume memory because it thinks like it has it. So just stop. So if we put one more tiny addition, which is please don't swap, and save the same 128 megabytes. What will happen? Yeah, kind of. Silently. And we already know what to do. Look at the system journal, red lines, no memory. It's so simple. All right, let's finally put a proper limitation, like 700 megabytes. That's nice. Let's keep an eye on that process. Look at the Docker stats. It started to consume memory, but this time I won't forget putting a load on it. What will happen? So it starts. Oh, something happened. 700 megabytes. Woo. So don't do this at home. Don't try older JDKs. Please try newer ones. Like JDK 11, long-term supported version. And moreover, what I've put here, I made it be runnable as a WinJar. Not bad. This looks scary, right? But in fact, is an expansion of this. So you can write scripts that are okay, not taking 10 lines. Just in this console, it's expanded and you see all the jars involved, all the class path. Also, so around Liberica Alpine container here, I limit just-in-time compilation, so I don't want it to be too effective because it consumes more code cache, so I will save some memory, not losing too much throughput in this application. And it will also give me better startup, so I switch to this flag, and also I have startup improvements of JDK 11 and the recommended way of running getting better startup in Spring Boot. I going from FatJar to WinJar. So what will happen? It will start and it will work, and it will start in about 10 seconds. Let's check that. 2 times improvement. Of course not milliseconds, but it's the Spring we all love. Yeah. True inversion, dependency and version control container. So, yeah. Did it start? I haven't noticed. Oh, we have health check. It's up. And by the way, Gmeter is still running. And the process is alive. And it consumes much less than 256 megabytes. Not bad. We improved stability of our application by just changing a few lines in our start script. And it still runs, well, it now runs in a good container, automatically configured, no extra Java settings except some optimizations that I put. Why not? Okay. So what's next?
Oh, what could be better than that?
Yeah, we improved our startup time from like 20 seconds to 10 seconds, but I consider it being still slow, and I think we can save more memory. So we switched to JDK 11, which means we have now AppCDS available in our JDK. And we can create shared archive for this application, well, which may be a bit tricky. Because as we discussed earlier. It may be FATJAR or FinJAR. In FATJAR, all your libraries are hidden, and so they are just resources inside the jar in lib folder somewhere, and all classes are loaded by a special Spring Boot class loader, which looks there, extracts necessary classes. First, well, you have to find jar and then classes from the jar. And if you apply class data sharing for that application as is, you will see only a few classes that are loaded by system class loader. There are means of bypassing this. For example, there's a nice utility called CL for CDS by Volker Simonis, which is able to extract write information from your app, even if it's a FATJAR. But in case of FinJAR, it's okay to dump class information. What's interesting here is that I do this using same container because the way how it works really depends on how you run it. For example, how do you think, what was the garbage collector in our last run? Then I put container limitations and things like that. So it was JDK 11. What's the default garbage collector? It had no GC options. G1 GC. But you know, it was serial. Because we limited memory too much, and it decided it is a kind of client machine, and yeah. So it became a serial GC. It became using serial GC. You can switch off that behavior by putting a special flag, which is called always act as a server machine. Or you can ignore it, but still use the container to have exactly the same defaults. So here we use the container to build CDS archive and put it on a volume. And we also have very same class path. And what is also good here is it is a static class path. So all jars are listed with their exact paths, which allows AppCDS to work. So it is a long story of using just one feature, but this feature is a cool one. When we create shared archive and put it in a volume, we can first make even one instance of that process benefit, because it will use less memory and it will start faster. Because classes won't be like loaded, internal structures won't be created, will be just memory mapped from disk to memory. But also we can share that shared archive between different instances of the same container. So it worked. So have you ever tried AppCDS before? So it's available in Oracle Java 8 and in new OpenJDK. Finally, we can run FinJAR with previous optimization settings. We can provide a shared archive, which we created recently. Like before that, I made a class list, of course, so it's a two-step process. I just skipped the first step. And this archive is located on volume, and we can mount that volume to any number of instances on the same container. And the actual data will be shared among them. as if there was no containers. It works the same. So we start at finjar in just, it should be 7 or 8 seconds. Okay. Okay, started Hello World application in 7.745 seconds. Not 20. And even not 10. It's healthy. Gmeter still works. Oh, by the way, not bad. About 2K requests per second. What about diagnostics? It consumes slightly above 100 megabytes a peak. All right, let's make some fun. Let's deploy a lot of such containers. Using my favorite orchestration tool, which is called Bash. No, yeah, you know, it's so handy. And I prefer real programming languages. So we start 95 instances of same container, providing same limitations, small. We also put JFR options here. By the way, the port must be the right one. So you see, we forward the port. So yes, same service, started as a finjar, but many times. So it's kind of must start. All right, here we go. Check Docker stats. All right, it is a funny part. Everything works. They all consume memory below our desired limits. And Gmeter still works. Anyway, second service is up and running. That's all fine. And they start pretty quickly. Right? They share. So we saved even more physical memory by sharing fast data between those instances.
Your health check is hitting all of these?
No?
Your health check is hitting every one of these?
No, just first one.
Alright.
But we can change the port, or we can go there to the browser and check. All right, it's blinking. Let's get back to slides. Does it? Let's restart it. I like LibreOffice so much. Okay, it finally works. Like we're saying all of this, you know who it is now?
We get the joke.
It's culture. Okay.
A hat, nothing more.
So, first of all, first demo was about Liberica Alpine. It's not updated. Oh, it was updated. So, things in fact worked with JDK 12 and JDK 13 here. But try tomorrow. So with JDK 13, if you want to build image for Java base, there's some tiny problem that is being fixed right now. So don't worry. For JDK 11, it will be latest security update, 11.04. Yeah, no problem here. So, what we've seen, that we can start the process without looking at latest stuff. Just we blindly had some old Java in our production. We decided to add some containers, some limitations. Well, it died. Nobody cared, or maybe someone cared, but well, what shall we do? We can go and check using either Docker means or system tools, which is preferable because well, the information from Docker disappears after some time. And we can solve that by putting enough memory. Sometimes it's the right thing. It will continue to work after that. So we can use JDK tools to find out actual amount of native memory we need. Then we can put some load. Process may die or may not die, you know, or it may start swapping until it becomes too lazy, too slow, and again it will be killed. But we can check. We can check swap information. We can check actual memory consumed by this JVM, asking it about its flags or current memory consumption. That may be slow. We finally can fix that by disable swappiness, put in real amount of physical memory we need, because well, swap and Java are just things from different worlds. Well, for now. One thing that was not covered in demo is ahead of time compilation, which may be considered as a helper for startup time, but not in this case. And to be honest, I don't know good cases for that. Probably in your application you may find one. So, as an example, here on slides, it's some shell magic to convert JVM information that JVM gives you to JVM information that JVM consumes. So we may capture all methods that were executed until some point at our program execution, and then convert it into a list for AUT compiler available in, for example, JDK 11. And then we can create AUT stuff, AUT libraries, SO libraries. While, again, in this case, on all steps, it's preferable to use the same container to get the same flags that, again, influence how JUTC work. Or you can specify exact flags first, finding out which flags, what are values for flags, like what GC is used, other things. And you can create SO files. You can do it with fedjar, but probably you will be unlucky. The same story as with AppCDS. Those classes have to be loadable. So resolution should go the same path. Self-in-jar is easier here, and it works. But it doesn't help. So we can create different libraries, like only Spring Boot classes, only like hot methods, all methods executed at startup, all methods at all. It just doesn't help. But AppCDS do help. Again, as I mentioned, a few steps here. First, you dump a list of classes at some point using either tool, like for example JDK functionality if you use WinJar. Then you create shared archive using that list of classes. And then you finally use that shared archive in your runs. And we got nice improvements. 6 times less physical memory necessary for our process to run, and 2.5 times better startup. And it doesn't break. It works under heavy load. So Java now works well in containers. Please use latest updates, latest Java. Put it in containers. It's fine. No performance problems, no functional issues so far. If you have issues, you know, you can get support. Or you can just write blog post and we'll see it. So that's pretty much it about Java and containers. Thank you.
Questions?
If you didn't use a memory limit, what would the default heap size be? Percentage of RAM or?
The container will see a limit as entire physical memory available at the machine.
And it's for free?
I have a question.
Yeah.
Would you be able to make these slides available so we can keep these tips?
They are available. Yeah.
Oh, okay. Where would they be?
That's a good question. I thought, yeah, I can put it somewhere.
Send them to me
Yeah,
and we
I'll
post
send
them
them to
around.
Paul.
Yeah.
Probably.
These are good tips.
Yeah.
How did you generate the class list for the shared archive?
It can be done by using just the regular dump loaded class list functionality. There's my mouse pointer. This one. So the first step here, it's a special flag for JVM that will print it on exit. So we run our application until some point and then stop it and it dumps loaded class list.
So it dumps it into hello-exe.
Yeah, yeah. It should be called like thing class list. Yeah, we can look at this file. Let's do it. Okay. Here's my console. They all started. Maybe let's stop it.
Yeah.
Okay. So, by the way, when we use that flag for fedjar and finjar, as I said, we have different results. So we may look how different they are. So how many classes here? It's like 2,600. That's for fedjar. And for finjar, oh, sorry.
Really thin.
But like it's 6,800.
So 4,000 classes were jammed into the jar for the fat jar.
Yeah, no. So fedjar, in fedjar, 2.5 thousand classes are loaded if system class loaded. So they are visible to this flag. But if you use finjar, it's like 3 times more. Which makes our shared archive to be more effective because we share more data. And let's look inside. It's that simple. So you can write it by your own hand.
If you really hate yourself.
Yeah, there's one, let's check. Yeah. Okay, this one is a bit more complicated. This is an input file for AUT. A list of methods to compile. Yeah, that was.
So if you compare Liberica to other OpenJDKs, what would you say are the major differences?
There are differences. First of all, you heard about testing and DCK. This is one of the differentiators. What else? For example, Amazon really does kind of fork, because they ported a lot of stuff ahead of time, and they also provide different security provider. All is different, but they offer real support. That's the main thing, because when you compare the other JDKs built from upstream, they are more or less the same, and it's a good thing that you can switch. So you may like a different box, like better containers or better DMG installers or something. That's also the case.
Okay, no other questions? Great, thanks Dmitry.